reinforcement, because you know that our slab is usually in a matted format. Okay, we usually have our slab in this manner. Okay, we usually have it in this manner. So we have to know the spacing. So the spacing now maybe from here to here, this to this. Okay, so the spacing now is what we are looking for at the end of the design, because already we have already known that the diameter of the rebar is 12 millimeter. Okay, is 12 millimeter. So all we need to do at the end of each of the design, we are expected to define or come up with the spacings, okay, that this reinforcement is to be placed center to center. Okay, the center to center, I mean, like this reinforcement is at center to this reinforcement and center to this reinforcement. So as you're placing, if they are placed center to center. So it is important that we understand this aspect critically, because this is the let's say the essential aspect that will give us a clear perspective on how to design our slab. Because if you don't define this, okay, it means that there will be some lapses in the course of designing. Now the boundary condition also gives us guideline on how to place our reinforcement. Okay, because you know there are placements where we have maybe a particular stretch, maybe a particular, you know, we have what we call continuous beam structure. We can also consider a slab as continuous when we have more than when we have 2 spans, okay, and 3 supports. We can have 4 spans, 5 spans, like that. Okay, so when you have such a scenario, it is considered as a continuous slab or a continuous beam. So most times for the beam, it is more economical to design, to analyze such a beam as continuous. Okay, because by the time you do it as simply supported, it is uneconomical. So when you design as a continuous beam or a slab, you're expected to come up with the highest moment that is generated in those various span, because I told you that span is the distance between one support to the other support. So you discover that you might have more support at a particular span. Maybe the next span might be smaller, the next span, so there is a kind of maybe it's not symmetrically arranged. So that is also applicable to the amount of moment that will be generated. So ideally, if you're now designing for the slab or the beam, as the case may be, you must design with the highest moment that is generated. That is the highest span moment that is generated. That is